So hello and welcome back. So in this video we want to do example number 1 on page 578 and the example is sketch an angle of 30 degrees in standard position. So the question has two parts. A is 30 degrees in standard position, and the part B of the question is sketch an angle of negative 135 degrees in standard position. So we want to sketch these two angles. So first of all, whenever you want to sketch an angle, you, of course, in standard position means that however your angle, for example, this is approximately a 30-degree angle, something like this. Now you can see that this angle is not in standard position because I can keep moving this angle around. Again, this is a 30-degree angle. This is a 30-degree angle, and so on and so forth. But these 30-degree angles are not in standard position. They're just if I take this, the initial side of the angle, it's somewhere in space, and I keep moving it. So it's just not the standard position. But it helps always to know what a 30-degree angle looks like, because it's basically based on a triangle that is 30, 60, 90. So if this is a right triangle, this is approximately this is basically a 90-degree angle. Well, this becomes a 30-degree angle, and then this angle becomes a 60-degree, twice the size of this angle. And so a 30-degree angle is basically an angle of this size, approximately of this size. Now, usually what I do is that because it's always helpful to visualize what sort of angle you have, because when you have a unit circle in standard position, means that you have a unit circle like this. So we have not talked about the unit circle yet, but I can talk about it right here, so to just get it out of the way. So this is a unit circle, and the radius of this circle is 1 unit in all directions. So 1 unit here, 1 unit here, and 1 unit here. And so this becomes the radius of your circle. And in this circle, all of the angles that you draw are essentially in this circle. Although in the book, when you begin here in an angle in a standard position, is just you draw basically a Cartesian, something like a Cartesian coordinate system, and then this side becomes the initial side of your angle, and then you keep moving in a counterclockwise direction, and some 30-degree angle like this then is somewhere right here, and so this becomes a 30-degree angle in that system. So this is a 30-degree angle. But you can basically do it in you can do it directly in a unit circle. And as I mentioned, a unit circle is just a circle on a Cartesian coordinate system. The center of the circle is on the center of the Cartesian coordinate system, and the radius of this circle is 1 unit in all directions, of course. And so then this angle goes inside this unit circle. This is a 30-degree angle, and you can of course constitute a triangle over here, and you can see that you have a 90-degree angle here, a right angle here. This is 30 degrees, and this angle up here is 60 degrees. So whenever I want to draw these angles, or whenever I want to visualize them in my mind, because you need to know basically in what quadrant your angle happens to be. For example, if you have a 30-degree angle, it falls in the first quadrant. If you have a 135-degree angle, it becomes something like this, and it falls in the second quadrant. If you have a, I don't know, 230-degree angle, it comes somewhere right here, and then it falls in the third quadrant. And if you have a 280-degree angle, something like this, it falls in the fourth quadrant. So it's always helpful to know in what quadrant your angle lies, or in what quadrant your angle falls. So it's not really important to know to have the exact measure of the angle on your sketch paper. Usually not very important, but it's important to understand in what quadrant it lies, or it falls. So when I want to draw a 30-degree angle in standard position, all I need to do is have this Cartesian coordinate system. This is my x-axis and this is my y-axis. And well, you could draw your circle, or you could forget about your circle if you don't need it, but you already know that the unit circle already lies on these axes. And then a 30-degree angle is just some angle like this. So it's just a some angle like this. This is 30, this is 60, and this is 90-degree, a triangle. So you can simply transfer this triangle over to this Cartesian coordinate system. This is the vertex of the angle, and this is the center of the Cartesian coordinate system, and then it becomes some angle like this, and this is 30 degrees. And of course, when you want to draw it, you have to move in a counter clockwise direction. If you were to draw a negative 30-degree angle, you would move in a clockwise direction, and then it would be some angle like this. So this angle is negative 30 degrees. So that's that. But now, if you happen to really need the exact measure of the angle, let's say on a very precise sketch paper, on a piece of sketch paper, then you can use those ratios that we talked about in the previous video. So we want to do a 30-degree angle. So a 30-degree, you can take the ratio of get the ratio of the 30 degrees by 360 degrees, because the whole circle over here, starting from here and going back to where you started, the whole thing is 360 degrees. So 30 degrees out of 360 degrees, you can calculate what fraction of the circle it becomes. So it's basically 3 by, you can simplify this as 3 divide both the numerator and the denominator by 10, and you would get 3 divided by, you can forget about the angle sign for now as well, 3 divided by 36, and then divide both the numerator and denominator by 3, you would get 1 divided by 12. So 1/12 of the whole circle becomes your angle, which is 30 degrees. And 1/12 again is not very convenient, because you would have to divide the whole circle into 12 exactly equal distances around the circle, and then take one of those distances. So in order to do that, you can write this as 1/3 times 1/4. So you can basically take 1/4 of the whole circle. 1/4 of the whole circle becomes this point right here. So if you want to go starting from here, if you go all the way around the circle, becomes one time. If you want to go 1/4 of the way, you will end up here. So that is 1/4 of the way around the circle, and then you have 1/3 of that 1/4. So this is 1/4, and now 1/3 of this fraction of the circle becomes, basically you have to divide this whole angle into 3 equal parts, and then take one of those parts. So this is one equal part, and this is another part. So now you can see that this angle is equal to this angle is equal to this angle, because I have divided this whole 90-degree angle equally into 3 equal parts. And then out of these 3 equal parts, I take just one of the parts, which is basically this part, and then this becomes this part, and this angle that we have happened to create here is the 30-degree angle. And of course it is a positive 30-degree angle, because I'm moving in a counterclockwise direction. I'm moving in this direction. If I were moving in this direction, it would be a negative angle. So that's basically the whole story here. And as the second part of the question, we want to create a negative 135-degree angle, negative 135 degrees. So negative 135 degrees is again there is another way to visualize this. Even in your mind, you can constitute this, that basically the Cartesian coordinate system that you have to draw these angles in standard position. Here you have 0 degrees, here you have 90, here you have 180. It just keeps you keep adding 45 degrees or 90 degrees to each axis over here. So you add 90 degrees to 0, you get to 90. You get 90 degrees to 90, you get to 180. You add 90 to 180, you get 270. And you add 90 degrees to 270, you get 360. So 135 degrees is nothing but 90 degrees plus 45 degrees. 90 plus 45 is 135. So again, moving in a counterclockwise direction, I come 90 degrees, I end up here, and then 45 degrees if you remember, we said that if you want to get from this axis to this axis, you have to add 90 degrees. And so half of the way would be 45 degrees. So that means if I stop here, this angle over here is 45 degrees, and this is 90 degrees. So 90 plus 45 is 135 degrees. So this is another way to visualize it. And again, another way to do that is, and of course this is positive 135 degrees. You have to do the same thing in the negative direction. In the negative direction, you move in this direction, it is negative 90 degrees. And then you need another negative 45 degrees, so you move half of the way over here. And this is 45 degrees, so this whole angle over here becomes negative 135 degrees right here. And the initial point, the initial side of the angle is always this, the positive x-axis direction. So, and another way to do that is you want to know what fraction of the circle is 135 degrees. So 135 degrees, you just divide it by 360 degrees, and you can simply forget about the degrees, the degree unit. So you need to simplify this. In order to simplify, you can divide by 5, for example. Let's see, let me see. If you divide this by 5, you will get 135 divided by 5 is 2 into 5 is 10. And then you have 35, and you get 7 here. So 135 divided by 5 is 27. And if you divide 360 divided by 5, 360 divide this by 5, you get 5 into 8 is 40, 5 into 7 is 35. And here you get a 10, basically you get a 2 into 5 is equal to 10. So it's 72. So it's 72. And 7 plus 2 is equal to 9. So this number is divisible by 3. 2 plus 7 is 9. So this number is divisible by 3. So you can still divide and simplify. And of course, there are some calculators that will give you the exact, the simplified version of this ratio. Let me see if I can do it with this calculator. For example, if you have 135 divided by 360, it gives you 3/8. This is the simplified version of this fraction. But you can of course you can, for example, divide this by 3, you will get a 9. You can divide this by 3, you will get a 72. By 3, you will get a 2 into 3 is equal to 6, and then you have a 12 here, so this is 4, so this is 24. And then again, you can divide by 3, you will get a 3, you divide by 3, you will get a 8, so it is 3/8. So this fraction 135, so that basically means that 135 divided by 360 is equal to 3/8. So you have to move 3/8 of the way around here. And 3/8 you can write it as 3 cannot be factorized, but so 3/8 you can write it as 3 by 2 into, for example, 3 into 1 by 4. So 2 into 4 is equal to 8, and 3 into 1 is equal to 3. So that means 3/2 of 1/4. 3/2 of 1/4, or 1/4 of 3/2. So again, you can do the same thing here. You can go 3/2 of a circle of the circle, 3/2 of the circle in a clockwise direction, because you're moving in a negative direction. So 3/2 is 1.5, 1 and 1/2. So 1 and 1/2 would be 1 and 1/2, or let's start, for example, with 1/4. So if you go 1/4 of the circle, 1/4 of the circle would be, if you start here, it would be easier to start with 1/4. So if this is the initial side, if you go 1/4 of the way, you will end up here in the negative direction, and then you will take 3/2 of this 1/4. So 3/2 is basically 1.5. So that means you are increasing this angle by 50%. Multiplying by 1.5 means that you're increasing by 50%. So 50% of this angle is 90 degrees. So 50% of that is 45 degrees. So you're adding 50% to this angle, so meaning that you're adding 45 degrees to this angle, and then 45 degrees is this angle, and so you will end up right here. And so this becomes negative 135 degrees. So basically you can do it in any way that you want, but essentially the easiest way is first to look at your angle. If it's a negative angle, you are essentially moving in the negative direction, in this direction, and then whenever you can break it up into smaller angles that fit into these quadrants. For example, 135 degrees is 90 plus 45. So you move 90 degrees here and another 45 degrees here, and this is simply your angle, instead of having to go through all of this calculation and everything that we did here. So basically whichever way works for you. So in the next example, we're going to do tried number 1 as well, to basically learn more about these angles. I'll see you in the next video.